In this lesson, you'll learn how to solve problems with scientific notation. So let's get started. So what is scientific notation? Scientific notation is an easy way to write very large or very small numbers. It's used in science and engineering to talk about quantities that are really big or really small. It's written in the form a times 10 to the nth power, where a is a number greater than or equal to 1 and less than 10, and n is an integer, meaning it's a positive or negative number. For example, 300,000 can be rewritten as 3 times 10 to the 5th power, and the decimal 0.00025 can be rewritten as 2.5 times 10 to the negative 4th power. Now follow along as I solve this problem. Which of the following numbers is written in scientific notation? Well, remember, scientific notation is written in the form a times 10 to the nth power, where a is a number greater than or equal to 1 and less than 10, and n is an integer. So looking at my options, it's either going to be B or D. And remember that the a, or coefficient in front, has to be greater than or equal to 1 and less than 10. And here, 0.3 is less than 1, so B cannot be correct. And D works because 5 is greater than or equal to 1 and less than 10, and it has negative 4 as the exponent, which is an integer. So my answer is D. Now it's your turn to practice. Pause the video and solve the problem. And when you found your answer, click play. Which of the following numbers is written in scientific notation? Here you need to find the number that's written in the format a times 10 to the nth power, where a is greater than or equal to 1 and less than 10. 16 is greater than 10, so that's not going to work. C does not work. And for D, 0.025 is less than 1, so that's not going to work. Here, 7.2 is greater than or equal to 1 and less than 10. And 5 is an integer. So the answer is B. Now let's talk about how to convert numbers to scientific notation. To convert a number to scientific notation, first move the decimal point until there is only one non-zero digit to the left of the decimal point. Then count the number of places moved. This number determines the exponent. For example, to convert the number 4,500,000 to scientific notation, first put the decimal to the right of the ones place, and then move the decimal point to the left, so the resulting number is greater than or equal to 1 but less than 10. So I'll move the decimal point 1, 2, 3, 4, 5, 6, which means the coefficient is now 4.5 times 10 to the 6th power, since I moved it over 6 places to the left, which makes sense because every time you move the decimal point 1 place to the left, you're making the number 10 times smaller. So to balance that out, the base of 10 gets a positive exponent, the same number of decimal places that you moved the point to the left. To convert the decimal 0.0000375 to scientific notation, you need to move the decimal point to the right so that the number is greater than or equal to 1 but less than 10. So in this case, I need to move the decimal point 1, 2, 3, 4, 5, 6. 6 places to the right, which means the resulting coefficient will be 3.75 times 10 to the negative 6th power, which makes sense because every time you move the decimal point 1 place to the right, you're increasing the value of the number by 10. So the base of 10 gets a negative exponent with that number of places you move the decimal point to the right, so that the value of the number stays the same. Now follow along as I solve this problem. Convert 650,000 to scientific notation. So I'll start by writing out the number, and then adding a decimal point to the right of the ones place. And then I need to move the decimal so the resulting number becomes greater than or equal to 1 but less than 10. So in this case, I'll move the decimal point 1, 2, 3, 4, 5 units to the left, which means the resulting coefficient will be 6.5 times 10, and in this case, I move the decimal point 5 units to the left, so the exponent will be positive 5, which makes sense, because when you move a decimal to the left, you are decreasing the number by a factor of 10. So to keep the value unchanged, you need to increase the exponent in the positive direction. So the answer is 6.5 times 10 to the 5th power. Now it's your turn to practice. Pause the video and convert 9,750,000 to scientific notation. And when you found your answer, click play. Start by writing out the number 9,750,000. And then add a decimal to the right of the ones place. Then move the decimal 1, 2, 3, 4, 5, 6 places to the left, which gives you a coefficient of 9.75 times 10 to the 6th power, because you moved the decimal point 6 places to the left. Now it's time for more practice. Pause the video and solve the word problem. And when you found your answer, click play. The distance from the Earth to the Sun is approximately 149.6 million kilometers. Convert the distance to scientific notation. So start by rewriting the number, 149,600,000. Then add a decimal to the right of the ones place. Then you need to move the decimal 1, 2, 3, 4, 5, 6, 7, 8 places to the left. So the resulting coefficient is 1.496 times 10 to the positive 8 power, because you moved the decimal point 8 places to the left. And make sure to add the units, which is kilometers. Now follow along as I solve this problem. Here I need to convert the decimal 0.00000082 to scientific notation. So I'll start by writing out the number. And then I'll move the decimal point to the right so that the number becomes greater than or equal to 1 but less than 10. So I'll move the decimal point 1, 2, 3, 4, 5, 6 places to the right. So the resulting coefficient becomes 8.2 times 10 to the negative 6th power, which makes sense because when you move a decimal to the right, you are increasing the number by a factor of 10. So to keep the value unchanged, you need to decrease the exponent in the negative direction. Now it's your turn to practice. Pause the video and solve the problem. And when you're done, click play. Here you need to convert the decimal 0.0000000 and then add 47. And then you need to move the decimal point to the right so that the resulting number is greater than or equal to 1 but less than 10. So you move 1, 2, 3, 4, 5, 6, 7, 8 places to the right. So the resulting coefficient is 4.7 times 10 to the negative 8. Now it's time for more practice. Pause the video and solve the word problem. And when you found your answer, click play. The diameter of an atom varies depending on the type of atom, but typically ranges from about 0.1 to 0.5 nanometers. For instance, the diameter of a carbon atom is 0.154 nanometers. Convert the diameter to scientific notation. So start by rewriting the number 0.154 0, 0, 0, 0, 0, 0, 0, 0, 0, 154. Then move the decimal 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 places to the right. So the coefficient becomes 1.54 times 10 to the negative 10th power, because you move the decimal point 10 places to the right. So the exponent will be negative 10. And then make sure to add the units, which is meters. Now let's learn how to perform operations with scientific notation. Performing operations with scientific notation involves adding, subtracting, multiplying, or dividing the coefficients of numbers written in scientific notation. These operations follow the same rules as regular numbers, but with the added step of adjusting the exponents in scientific notation. So just to review, the number in front, or the A, is the coefficient, which in this case is 5.7, times 10, which is the base, to the nth power, which is the exponent. First, let's talk about adding and subtracting with the same exponent. If both numbers have the same exponent, add or subtract the coefficients while keeping the exponent the same. For example, here we have 7 times 10 to the 4th power plus 5 times 10 to the 4th power. Since both numbers have the same exponent of 4, you can simply add the coefficients, which are 7 and 5. So that gives you 7 plus 5 times 10 to the 4th power. And 7 plus 5 is 12 times 10 to the 4th power. But here, 12 is greater than 10. So you need to convert it to a number that's greater than or equal to 1 but less than 10. So you need to move the decimal 1 place to the left. So that becomes 1.2. And since you moved the decimal point to the left, which means you decrease the number by a factor of 10, you need to increase the exponent by 1, so the value remains unchanged. So the 4 becomes 5. So the final answer is 1.2 times 10 to the 5th power. Next you have 9 times 10 cubed minus 2 times 10 cubed. In this case, both numbers have the same exponent of 3. So now you need to subtract the coefficients, which gives you 9 minus 2 times 10 cubed. And 9 minus 2 is 7 times 10 cubed. And since 7 is greater than or equal to 1 and less than 10, you can leave the coefficient the way it is. So the final answer is 7 times 10 cubed. Now follow along as I solve these problems. Here I have 2.5 times 10 to the 8th power plus 1.7 times 10 to the 8th power. Since both numbers have the same exponent of 8, I can go ahead and add the coefficients, which are 2.5 and 1.7. And 2.5 plus 1.7 times 10 to the 8th power gives me 4.2 times 10 to the 8th power. And 4.2 is greater than or equal to 1 but less than 10. So my final answer is 4.2 times 10 to the 8th power. Next I have 6.2 times 10 to the 5th power minus 5.8 times 10 to the 5th power. Since both numbers have the same exponent of 5, I can go ahead and subtract the coefficients, which are 6.2 and 5.8. And that gives me 6.2 minus 5.8 times 10 to the 5th power. And subtracting the coefficients gives me 0.4 times 10 to the 5th power. But here, the coefficient of 4/10 is less than 1, so I need to move the decimal 1 place to the right, which means I'll have a new coefficient of 4 times, and since I moved the decimal point to the right, which increased the value by a factor of 10, I need to decrease the coefficient by 1, so the value of the number remains unchanged. So that gives me 10 to the 4th power. So my final answer is 4 times 10 to the 4th power. Now it's your turn to practice. Pause the video and solve the problems. And when you found your answers, click play. Here you have 9.6 times 10 squared plus 2.8 times 10 squared. In this case, both numbers have the same exponent of 2, which means you can go ahead and add the coefficients, which gives you 9.6 plus 2.8 times 10 squared. And 9.6 plus 2.8 equals 12.4 times 10 squared. But here the coefficient is greater than 10, so you need to move the decimal point one place to the left. So the new coefficient becomes 1.24. And since you move the decimal point to the left, you decrease the value by a factor of 10. So to make sure the value stays unchanged, you need to increase the value of the exponent by 1. So that becomes 10 cubed. So the final answer is 1.24 times 10 cubed. Next you have 4.5 times 10 to the 6th power minus 1.3 times 10 to the 6th power. In this case, both numbers have the same exponent of 6. So go ahead and subtract the coefficients, which gives you 4.5 minus 1.3 times 10 to the 6th power. And 4.5 minus 1.3 equals 3.2 times 10 to the 6th power. And since 3.2 is greater than or equal to 1, but less than 10, this is your final answer. Now it's time for more practice. Pause the video and solve the word problem. And when you found your answer, click play. A research team is conducting a science experiment to measure the distance traveled by two particles. The first particle travels 4.2 times 10 to the 5th meters, while the second particle travels 6.8 times 10 to the 5th meters. What is the total distance traveled by both particles? In this case, you need to solve for the total distance, which means you need to add the two distances, which gives you 4.2 times 10 to the 5th power plus 6.8 times 10 to the 5th power. Since both numbers have the same exponent of 5, you can add the coefficients. 4.2 plus 6.8 times 10 to the 5th power. 4.2 plus 6.8 equals 11 times 10 to the 5th power. But 11 is greater than 10, so you need to move the decimal one place to the left, which gives you the new coefficient of 1.1. And since you move the decimal point to the left, which makes the number 10 times smaller, you need to offset that by adding 1 to the digit in the exponent. So 10 to the 5th power becomes 10 to the 6th power. And then make sure to add the units, which is meters. So the distance traveled by both particles is 1.1 times 10 to the 6th power meters. Now let's talk about adding and subtracting with different exponents. When adding or subtracting scientific expressions with different exponents, you first need to rewrite them so they have the same exponent. For example, here we have 3 times 10 to the 4th plus 5 times 10 cubed. In this case, the expressions have different exponents, 4 and 3. So it would be easier to convert 10 to the 3rd to 10 to the 4th. So you need to move the decimal point one place to the left. So the new coefficient becomes 0.5. And since you move the decimal point to the left, which decreases the value by a factor of 10, you need to offset that by increasing the value of the exponent by 1. So that becomes 10 to the 4th. Now that gives you 3 times 10 to the 4th plus 5/10 times 10 to the 4th. And now you have the same exponent. So you can add the coefficients, which gives you 3 plus 5/10 times 10 to the 4th. And 3 plus 5/10 is 3.5 times 10 to the 4th power. And since 3.5 is greater than or equal to 1 but less than 10, this is the final answer. Next you have 8 times 10 to the 6th power minus 2 times 10 to the 5th power. And once again you have different exponents. And in this case it would be easier to convert the 5th power to a 6th power. So once again you need to move the decimal point one place to the left. So the new coefficient becomes 0.2. And since you moved it to the left, which is decreasing it by a factor of 10, you need to offset that by adding 1 to the exponent. So that becomes 10 to the 6th power. And now you have the same exponent. So that gives you 8 times 10 to the 6th power minus 0.2 times 10 to the 6th power, which gives you 8 minus 0.2 times 10 to the 6th power. And 8 minus 0.2 is 7.8 times 10 to the 6th power. And since 7 is greater than or equal to 1 but less than 10, this is the final answer. Now follow along as I solve these problems. Here I have 4.5 times 10 to the 4th plus 3.7 times 10 cubed. In this case, I have different exponents, so I need to make them have the same exponent. And in this case, I can change the 10 cubed to 10 to the 4th by moving the decimal point one place to the left. So the new coefficient becomes 0.37. And since I moved it to the left, I can add 1 to the exponent. So that becomes 10 to the 4th. And now I have the same exponents. So I can go ahead and add the coefficients, which are 4.5 and 0.37 times 10 to the 4th power. And 4.5 plus 0.37 is 4.87 times 10 to the 4th. And that's my final answer. Next I have 6.9 times 10 to the 8th power minus 2.5 times 10 to the 7th power. And once again, I have different exponents, so I need to make them have the same exponent. So I can move the decimal point in the second number one space to the left, which gives me the coefficient 0.25. And since I moved the decimal point to the left one space, I need to add 1 to the exponent. So the 10 to the 7th becomes 10 to the 8th. And now I have the same exponent. So I can go ahead and subtract the coefficients, which is 6.9 minus 0.25 times 10 to the 8th power. And 6.9 minus 0.25 is 6.65 times 10 to the 8th power. And that's my final answer. Now it's your turn to practice. Pause the video and solve the problems. And when you found your answers, click play. Here you have 2.8 times 10 to the 9th power plus 6.5 times 10 to the 8th power. And here the exponents are different, so you need to make them the same. And it would be easier to convert 10 to the 8th power to 10 to the 9th power by moving the decimal point one place to the left. So the new coefficient becomes 0.65 times 10 to the 9th power, because when you move the decimal point one place to the left, you need to increase the exponent by 1. And now the exponents are the same, so you can go ahead and add the coefficients, which gives you 2.8 plus 0.65 times 10 to the 9th power. And 2.8 plus 0.65 equals 3.45 times 10 to the 9th power. And that's the final answer. Next you have 9.3 times 10 to the 5th power minus 1.8 times 10 to the 4th power. Once again you have different exponents, so you need to make them the same. And in this case, it would be easier to convert 10 to the 4th to 10 to the 5th by moving the decimal point one place to the left. So the new coefficient becomes 0.18 times 10 to the 5th. And now the exponents are the same. So go ahead and subtract the coefficients. So that gives you 9.3 minus 0.18 times 10 to the 5th power. And 9.3 minus 0.18 is 9.12 times 10 to the 5th power. And that's the final answer. Now it's time for more practice. An astronomer is analyzing the sizes of two different stars. The radius of the first star is measured as 3.5 times 10 to the 6th kilometers, while the radius of the second star is measured as 2.1 times 10 to the 7th kilometers. If they want to find the difference in radii between the two stars, what is the result? In this case, you want to find the difference, which means you need to subtract. And you need to subtract the smaller number from the bigger number. And in this case, 3.5 times 10 to the 6th is smaller than 2.1 times 10 to the 7th, because 10 to the 6th is a whole exponent smaller than 10 to the 7th. So to rewrite that, you would write 2.1 times 10 to the 7th minus 3.5 times 10 to the 6th. And here you have different exponents, so you need to convert them to the same exponent. And in this case, it would be easier to convert the second number from 10 to the 6th to 10 to the 7th by moving the decimal point one place to the left. So the new coefficient becomes 0.35 times 10 to the 7th. And now you have the same exponents, so go ahead and subtract the coefficients, which gives you 2.1 minus 0.35 times 10 to the 7th power. And 2.1 minus 0.35 is 1.75 times 10 to the 7th power. And make sure to add the units, which is kilometers. So the difference in the radii between the two stars is 1.75 times 10 to the 7th kilometers. Now let's talk about multiplying numbers in scientific notation. When multiplying numbers in scientific notation, multiply the coefficients together and add the exponents. So first we have 2 times 10 cubed times 5 times 10 squared. So start by multiplying the coefficients together, which are 2 and 5. So that gives you 2 times 5. And then we need to add the exponents, which are 3 and 2. So that gives you times 10 to the 3 plus 2 power. And when you're multiplying numbers, the exponents do not have to be the same. They can be different. So that gives you 2 times 5 is 10 times 10 to the 3 plus 2 is 5. That gives you 10 times 10 to the 5th. But 10 is not less than 10, so you need to move the decimal over one place to the left. So that becomes 1.0 times 10 to the 6th power. Because when you move a decimal point to the left, you're decreasing the value by a factor of 10. So you need to offset that by increasing the value of the exponent by 1. So the answer is 1.0 or 1 times 10 to the 6th power. Next we have 7 times 10 to the 9th times 3 times 10 to the negative 3rd. So start by multiplying the coefficients, which are 7 and 3. So that gives you 7 times 3. And then add the exponents, which are 9 and negative 3. So that gives you times 10 to the 9 plus the negative 3 power. And 7 times 3 is 21 times 10 to the 9 plus negative 3, and 9 plus negative 3 equals 6. But once again, the coefficient is greater than 10, so you need to move the decimal point one place to the left. So that becomes 2.1 times 10 to the 7th power, and that's the final answer. Now follow along as I solve these problems. Here I have 2.6 times 10 to the negative 3rd times 3.4 times 10 to the negative 6th. So I need to start by multiplying the coefficients, which gives me 2.6 times 3.4 times 10, and then add the exponents, which are negative 3 and negative 6. And 2.6 times 3.4 is 8.84 times 10, and negative 3 plus negative 6 equals negative 9. So the answer is 8.84 times 10 to the negative 9th power. Next I have 8.1 times 10 to the negative 7th times 5.9 times 10 to the 4th. So I need to start by multiplying the coefficients, which gives me 8.1 times 5.9 times 10 to the negative 7 plus 4. And 8.1 times 5.9 is 47.79 times 10, and negative 7 plus 4 equals negative 3. But here you can see that the coefficient is greater than 10, so you need to move the decimal point one place to the left. So the new coefficient becomes 4.779 times 10, and in this case, since you moved the decimal point one place to the left, which made it 10 times smaller, you need to offset that by adding 1 to the negative 3. And negative 3 plus 1 is negative 2. So my final answer is 4.779 times 10 to the negative 2nd power. Now it's your turn to practice. Pause the video and solve the problems. And when you found your answers, click play. Here you have 3.5 times 10 cubed times 6.2 times 10 to the negative 8th. So start by multiplying the coefficients, which gives you 3.5 times 6.2 times 10, and now add the exponents, which are 3 and negative 8. So that becomes 3 plus negative 8. And 3.5 times 6.2 is 21.7 times 10, and 3 plus negative 8 is negative 5. But the coefficient is greater than 10, so move the decimal point one place to the left. So the coefficient becomes 2.17 times, and since you moved the decimal one place to the left, you need to add 1 to the exponent, and negative 5 plus 1 is negative 4. So the exponent becomes negative 4. So the final answer is 2.17 times 10 to the negative 4th. Next you have 1.1 times 10 to the negative 5th times 5.7 times 10 to the negative 1. So start by multiplying the coefficients, which gives you 1.1 times 5.7 times 10, and then add the exponents, which are -5 and -1. -5 plus -1. And 1.1 times 5.7 is 6.27 times 10, and -5 plus -1 is -6. So your final answer is 6.27 times 10 to the -6th power. Now it's time for more practice. Pause the video and solve the word problem. And when you found your answer, click play. An engineer needs to calculate the power output of a generator. The generator produces 4.2 times 10 cubed watts of power and is connected to a transformer that increases the power output by a factor of 6.8 times 10 to the fourth. What is the total power output of the generator after it passes through the transformer? In this case, you need to find the total power output of the generator after it passes through the transformer. But in this case, you need to multiply instead of adding, because the power output is being increased by a factor. So you would do 4.2 times 10 cubed times 6.8 times 10 to the fourth. And now you can multiply your coefficients, which are 4.2 and 6.8. Times 10, and then add your exponents, 3 and 4. And 4.2 times 6.8 is 28.56 times 10, and 3 plus 4 is 7, 10 to the 7th power. But the coefficient is greater than 10, so you need to move the decimal point one place to the left. So the new coefficient becomes 2.856 times 10, and in this case, since you moved the decimal point one place to the left, which decreased it by a factor of 10, you need to offset that by adding 1 to the exponent, and 7 plus 1 is 8. And then add the units, which are watts. So the total power output is 2.856 times 10 to the 8th watts. Now let's talk about dividing numbers in scientific notation. When dividing numbers in scientific notation, divide the coefficients and subtract the exponent of the divisor, which is the second number, from the exponent of the dividend, which is the first number. So in this case, you're dividing 2 times 10 to the 5th by 8 times 10 squared. So start by dividing the coefficients, which is 2 and 8. So that gives you 2 divided by 8 times 10, and then subtract the exponents, which are 5 and 2. So that'll be 5 minus 2. And 2 divided by 8 is 0.25 times 10, and 5 minus 2 is 3, so 10 cubed. But here the coefficient is less than 1, so you need to move the decimal point one place to the right. So the new coefficient is 2.5 times 10, and since you moved the decimal point one place to the right, which means you're increasing it by a factor of 10, you need to offset that by subtracting 1 from the exponent. And 3 minus 1 is 2. So the final answer is 2.5 times 10 squared. Next we have 6 times 10 to the 8th divided by 3 times 10 to the -3rd. So once again we need to divide the coefficients, 6 and 3. That gives us 6 divided by 3 times 10, and then subtract the exponents, 8 and -3. 8 minus negative 3. And 6 divided by 3 is 2, times 10, and 8 minus negative 3 is equal to positive 11, because subtracting a negative is the same thing as adding a positive. So that becomes 8 plus 3, which once again is 11. And so the final answer is 2 times 10 to the 11th power. Now follow along as I solve these problems. First, I have 2.1 times 10 to the negative 8th divided by 4.8 times 10 cubed. Here I need to start by dividing the coefficients, 2.1 and 4.8. That gives me 2.1 divided by 4.8 times 10, and then subtract the exponents, which are negative 8 and 3. So that becomes negative 8 minus 3. And 2.1 divided by 4.8 equals 0.4375 times 10, and negative 8 minus 3 equals negative 11. But here the coefficient is less than 1, so I need to move the decimal point one place to the right. So my new coefficient becomes 4.375 times 10, but since I moved the decimal point one place to the right, which is the same as increasing it by a factor of 10, I need to offset that by subtracting 1 from the exponent. And negative 11 minus 1 equals negative 12. So my final answer is 4.375 times 10 to the negative 12th. Next I have 6.4 times 10 to the negative 3rd divided by 2.5 times 10 to the negative 1. So I need to start by dividing the coefficients, which gives me 6.4 divided by 2.5 times 10, and then subtract the exponents, which are negative 3 and negative 1. So that becomes negative 3 minus negative 1. And 6.4 divided by 2.5 equals 2.56 times 10. Negative 3 minus negative 1 becomes negative 3 plus 1, because subtracting a negative is the same as adding a positive, and negative 3 plus 1 equals negative 2. So my final answer is 2.56 times 10 to the negative 2nd power. Now it's your turn to practice. Pause the video and solve the problems. And when you found your answers, click play. First you have 4.5 times 10 to the 5th divided by 1.5 times 10 squared. So start by dividing the coefficients, 4.5 and 1.5. And then subtract the exponents, 5 and 2. 5 minus 2. And 4.5 divided by 1.5 equals 3 times 10, and 5 minus 2 is 3. So the answer is 3 times 10 to the 3rd power, or 3 times 10 cubed. Next you have 5.2 times 10 to the 4th divided by 6.4 times 10 to the negative 3rd. So once again, start by dividing the coefficients, 5.2 and 6.4. And then subtract the exponents, 4 and negative 3. So that becomes 4 minus negative 3. And 5.2 divided by 6.4 equals 0.8125 times 10, and 4 minus negative 3 becomes 4 plus 3, because subtracting a negative is the same as adding a positive, and 4 plus 3 is 7. But here the coefficient is less than 1, so you need to move the decimal point one place to the right. And since moving the decimal point one place to the right is like multiplying by 10, you need to offset that by subtracting 1 from the exponent. So that becomes 8.125 times 10, and 7 minus 1 is 6. So the answer is 8.125 times 10 to the 6th power. Now it's time for more practice. Pause the video and solve the word problem. And when you found your answer, click play. Scientists are observing the growth of bacteria in a petri dish. At the beginning of the experiment, there are 6.4 times 10 to the 4th bacteria in the dish. After 6 hours, the population has increased to 4.8 times 10 to the 6th bacteria. By how many times has the population increased during this time period? In this case, you need to find out by how many times has the population increased, which means you need to divide. You need to divide the ending value by the starting value. So the ending value was 4.8 times 10 to the 6th divided by the starting value, which was 6.4 times 10 to the 4th. Now divide the coefficients, 4.8 and 6.4, which gives you 4.8 divided by 6.4 times 10, and then subtract the exponents, which are 6 and 4. 6 minus 4. And 4.8 divided by 6.4 equals 0.75 times 10, and 6 minus 4 is 2. But here the coefficient is less than 1, so you need to move the decimal point one place to the right. Since you're moving the decimal point one place to the right, which is the same as multiplying by 10, you need to offset that by subtracting 1 from the exponent. So that gives you 7.5 times 10 to the 2 minus 1 is 1, or 10 to the 1st power. And since 10 to the 1st power is simply 10, you can multiply 7.5 times 10 to get your answer. 7.5 times 10 is 75. So the population of bacteria got 75 times larger. Hey, it's Nicholas, creator of Mathemy, and if you like this video and want to take your math skills to the next level, check out my online course, Pre-Algebra Made Easy. Whether you're preparing for algebra, geometry, or a standardized test like the GED, ASVAB, or GRE, this course is for you. Dive into interactive videos where you'll shadow me through problems, then take the reins to practice solo. Worried about making mistakes? Don't be. I'll walk you through each solution, making sure you understand every step. But it doesn't stop there. Quizzes, practice activities, and detailed answer keys will solidify your understanding. Cap it off with section tests and an end-of-course exam to showcase your new skills. Mastering pre-algebra is the key to future success in math and beyond. Click on the link in the description below to enroll now and start your journey to math mastery. I'll see you there.